What do you call people who are in favor of tractors? Protractors. Get it? Protractors. Measuring an angle. Anyways, we won't be using protractors to measure angles, but we'll still be able to prove they are congruent. And what we're going to use to do that is something called Cpctc. So what is Cpctc? Well, at the beginning of this unit, we said that corresponding angles and sides are congruent if and only if the two polygons are congruent. So the converse, switching that, means that the polygons are congruent, or in this case triangles, then their corresponding parts are congruent. What does that look like? You might be given a statement where you can see triangle is congruent to triangle. Then you can say, oh, I can say this side's congruent to the corresponding side, and the corresponding angle is congruent to the corresponding angle. So you can see where Cpctc comes from. It's the first part of most of the letters of corresponding parts of congruent triangles are congruent. But math people don't like to write too much, so we shortened it to Cpctc. So some things to keep in mind for using Cpctc. It proves that parts of triangles are congruent. That means angles or segments, sides. It does not prove that triangles are congruent. You need to use it, prove that the triangles are congruent or know that before you use Cpctc. So the steps are, write down which two angles or sides need to be proven congruent. That's your prove part. Then prove the triangles are congruent by using one of the theorems we already learned, either side, angle, side, 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 angle, side, angle, 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 side, and hypotenuse, leg. Finally, once you prove the two triangles are congruent, then you can say the two parts are congruent, either the two sides or the two angles, and use the reason Cpctc. So in this example, I'm going to prove that diagonals of a rectangle are congruent. So first of all, I have ABCD as a rectangle, and I have that as given. Now I'm going to go ahead and show the diagonals here so you can see what we're trying to do. This could get kind of messy, so ideally I would actually separate these two triangles out. Now it wants to say angle A, this big one, which is right there, is congruent to angle B. Is that true? For these two triangles, you can see that it is because they are both right angles, and all right angles are congruent. Then it says that AD is congruent to BC. So I have it drawn on the original rectangle. Then I have it on the corresponding side for the triangle. So you can see both of these are congruent. Why can I say that? Well, definition of a rectangle. If I had more room, I might say opposite sides of rectangles are congruent. Finally, I can say that AB is congruent to AB, that something is congruent to itself, and you can see it shows up on both triangles. That's the reflexive property of congruence. So finally, you can see I have side, angle, side, side, angle, side. So I can say that both triangles are congruent. ADB is congruent to CBA. Let me see. ADB is congruent to CBA. And I think I have my order off on those. So let me fix that. Pointer. So ADB is going to be congruent to BCA. So this should be right here. Cross that out. BCA. And the reason I can say that is side, angle, side. Finally, I can say that AC is congruent to DB, and the reason is after I prove the triangles are congruent, I can use Cpctc to prove that the rest of the parts are congruent. In this example, we have EFG, which is a triangle's isosceles with vertex F. And I want to prove that the median is also an angle bisector. Well, first of all, I write down my given, and I know that angle E is congruent to angle G. You can see I have it marked there. And the reason is, well, that's an isosceles triangle. The base angles are going to be congruent. Similarly, I can say that EF is congruent to FG because the legs of an isosceles triangle are congruent. That's the definition of an isosceles triangle. Now I can also say that EH is congruent to GH. And the reason is that median is going to cut it there. You could say since it was in the picture it was given, but since I mentioned that the median, FH is a median, we can also assume that it's congruent. So definition of a median. Now you can see that I have side, angle, side, and side, angle, side. So FEH is congruent to FGH, and that's by side, angle, side. Now I can prove that these two angles up here have to be congruent because of Cpctc, which means that FH is not only a median, if it's cutting it into two equal angles, it's also an angle bisector. So FH is an angle bisector because of the definition of an angle bisector. So one last thing to reflect on. What must you know or prove before you can use Cpctc to prove parts of a triangle are congruent? Remember, it does not prove that triangles are congruent. It proves parts.